So, Teddy?
Oh, yeah?
I've had a good think about this, and I've decided that you really are old enough now to know how the surface area of a sphere is related to its radius.
Really?
Yeah.
Yes! Okay. Tell me.
It's pretty simple.
Okay.
So that surface area is 4 pi times the radius squared.
Wait a second. This book here says the area enclosed by a circle is pi times the radius squared. You know what this means?
What?
That if you took a circle with the same radius as a sphere, that 4 of the area of that circle would be the same as the surface area of the sphere.
I guess that's right.
So you're telling me that if we had a basketball with radius r, and we made pancakes with radius r, that 4 pancakes would exactly cover the area of the basketball?
Well, if we made them perfectly.
Experiment! So right here, I am measuring half the circumference of the ball with the 0 point here, and I'm going to bend it all the way around over, and it's about 11 inches right there. Okay. So Andy measured the ball. Halfway around the circumference is about 11 inches. So we figure the circumference of the entire ball is like 22 inches. Now, if we're going to figure out the diameter of the ball, which we can use to find the radius, we're going to want to divide by pi, because pi times diameter is the circumference, right? Okay. So let's see. If it's 22 inches, 22 divided by pi is about, carry the 4, 7.007214. Why are you laughing?
We don't need anywhere near that number of digits.
Why not?
How accurately did Andy measure the basketball?
Well, I figured he took it to the lab and he took one of their, their atomic microscopes and made, very accurate measurements. It just happened to be exactly 22 inches.
We actually have video of what he did.
Oh.
And it was not anything like that.
Okay. So I guess if we're just working in approximations, then 7.007 is close enough?
We don't even need to do that. Look, 11 inches, it's kind of miraculous that it's 11 inches because we want to multiply that by 2, that would be the full circumference.
Okay.
And then dividing by pi would give us the diameter.
Right.
And there's a really good approximation to pi that's just perfect for this.
What is it?
Pi equals 22 over 7.
So you're telling me that 22 divided by 22/7 equals 7?
That's right.
Huh.
So we just make 7-inch diameter pancakes.
Okay. 7-inch pancakes!
Sunrise, sunset. Yes.
Alright, so we didn't trim our pancake perfectly to 7 inches because it's really hard to do that in the pan. So we're going to cut them down according to a guide. And so this circle is about 7 inches in diameter. So we're going to cut this pancake down until it's a perfect 7-inch circle. Awesome. All right, and now we have a pancake that's a perfect 7 inches in diameter. We just have to do this 4 more times and we'll be set. pancakes.
Yeah.
How are we gonna do this?
So why don't we just start off and see whether anything goes wrong with just taking a pancake and putting it on the ball.
We made quite a few measurements. We cut these into the pieces, and these are the puzzle pieces that we think we're going to be able to fit together to totally cover this ball in Pancake. And it's worth noting, for example, that we took this circular piece that was originally circular, and we cut a little pie shape out of it so that it can better cover the ball. So here, put this over like that, and originally it would have been like this with all this area overlapping. So we cut quite some area out, and now it covers the ball better like this with not so much overlap. And that overlap just occurs because you're trying to put a flat object over another curved object. Anyway, so we're going to take all these pieces and we're going to try to attach them and assemble them to fill this puzzle. And there are so many pieces, it's really difficult to sort of attach them all together, like holding them with just the 4 hands that we have. So we're going to use tape. Okay, we have taped the pancake to the basketball. So we have all these scraps, and these are going to have to cover this entire half of the basketball area, like that. Okay. So, why do you think that there's so much area left uncovered?
Well, I think that we just weren't careful enough in mapping our flat pancakes onto the curved surface here.
Gotcha.
And that we would have done a better job if we had made smaller pieces. It would have been harder to do, but with smaller pieces, then each small piece, any very small area of the ball is approximately flat. There's not much curvature over just some small region.
Gotcha.
So if we cut this up into small regions and covered it with small pieces, we would have done a better job. I think that, we're losing some area here. Look at this. See all that gap there? This is not really fitting to this curved surface very well. And I think we're losing area there.
Interesting. That makes sense. So if we had cut it into smaller pieces, kind of like we did with these little cuts right here on the circular ones, then we probably could have covered more of the surface. And if we had cut them into an infinite number of infinitely small pieces, we could have actually covered the entire surface.
Yeah, except we can't because there's you can't infinitely cut a pancake.
Okay. All right. Well, let's do the best with what we have, and then we'll take a shot of the final thing after it's all taped on.
Okay.
Okay. So here's the finished product. We've got quite a bit of it covered. All this is pancake. The only part where there's a big gap is right here, and so that's probably just because of these little areas, and it's difficult to put the flat objects onto a round surface like this. So, but it is really surprising, like even though the amount that we did cut it up, how much of a big gap we got. So, wanna go play basketball?
Sure.
Cool. This is the most excited Humperdinck has ever been about basketball, is when it's covered in pancake. Dad, pass it to me. He's trying to nibble on it. That's
Okay.
great. Okay. Woohoo! I was gonna catch